Hello and welcome to Vision Academy. In this video, we are going to learn binary subtraction. So let us take an example, 33 minus 13. So that will give us 20. Here, both of these two numbers are to be converted into its binary equivalent number. So we have to write first 33 and divide this number by 2, and we have to note down the remainder and quotient. We have to go on divide this given decimal number till the quotient becomes 0. Here I'll write 2 ones are 2, carries 1, so it will become 13. 2 how much are 13 or less than that? 2 6 are 12. Here 1 is the remainder. 2 8s are 16, remainder is 0 because 16 is exactly divisible by 2, hence remainder will become 0. So again divided by 2, 2 4s are 8, remainder is 0. 2 2s are 4, remainder is 0. 2 1s are 2, remainder is 0. Next 2 zeros are, and this quotient will become remainder. So as per basic mathematical rule that says when the numerator is less than denominator, then the numerator acts as a remainder and the quotient becomes 0. Yes, now let us write the first remainder as least significant digit and the last remainder as most significant digit. So we'll have to write the binary equivalent of this given decimal number from most significant digit to least significant digit. Here I have to write 1 0 0 0 0 1. 13 is to be converted into its binary equivalent. Divide this number by 2. 2 6 are 12, 1 is the remainder. 2 3s are 6, 0 is the remainder. 2 1s are 2, 1 is the remainder. 2 zeros are, and this quotient 1 will become the remainder. The first remainder is least significant digit and the last remainder is most significant digit. So we'll have to write it from bottom to top, that is most significant digit to least significant digit. You can notice that here we have got total 6 binary digits, but in the second number we have got only 4 binary digits. In order to match up with all the columns, we have to write two leading zeros first, then I have to write 1 1 0 1 1 1 0 1. Now let us start adding from the right hand side. So not adding, sorry, subtraction. 1 minus 1 will become 0. 0 minus 0 will become 0. Here I cannot subtract 1 from 0. I have to check out the borrow from the left hand side column. But in the left hand side column also we have got 0. Next we have to check out for 1. That is bit number 1 on the next left column. Here also we found 0 only. Again you can look for bit number 1. Here we found bit number 1. So what we are going to do is we are going to shift this 1 onto the next column, and this bit will become 0 and this 0 will get cancelled. So where exactly we want this 1? We want this 1 here. So shift this bit over here. So it will become 1 and here it will be cancelled. So again shift this 1 over here because we wanted this borrow over here. 1 0 is what? 2. So here let us write 1 0 is 2. How I am going to prove it? So here I'll write 0 into 2 to the power 0 because the positional weight of this 0 is 0 and 1 is 1. I'll write plus 2 to the power 1 into bit number 1. Now let us further simplify. 2 to the power 1 is 2. 2 ones are 2 plus 0 into anything is 0 is equal to 2. So here 1 0 binary digit represent 2. Now you can see 1 0 is 2. 2 minus 1 is what? 1. Now you can see we have got 1 borrow. 1 minus 1 is 0. 1 minus 0 is 1. 0 minus 0 is 0. Now we have to check out whether this binary number is equal to 20 or not. So how to do that? We can verify by its positional weight. So here we'll take the positional weight of this 0 is 0 1 2 3 4. I'll write bit number 1 into 2 to the power 4 plus next bit is 0 into 2 to the power 3 plus next bit is 1 into 2 to the power 2. The next bit is 0 into 2 to the power 1 and the next bit is 0 into 2 to the power 0. If you want you can take this 0 as well. Here I'm going to write plus 2 to the power 5 into 0. Now 0 into anything will be 0 only. 0 plus 2 to the power 4 means 2 is to be multiplied 4 times. 2 2s are 4, 4 2s are 8, 8 2s are 16. So 16 ones are 16 plus 0 into anything will become 0 plus 2 to the power 2 is 2 2s are 4, 4 ones are 4 plus 0 into 2 to the power 0 1 is 0 plus 0 into 2 to the power 0 is also 0. Here you can see 16 plus 4 will become 20. So whatever we got in binary digits, so that is equal to 20. Hence it is correct. Now let us take one more example of this kind. Here I am going to write for example 8 and then 1. So subtract 1 from 8, we should get 7. So convert this 8 and 1 into its binary equivalent. So how to do that? You can use the same procedure. Divide this given decimal number 8 by 2 and we have to note down remainder and quotient. So till quotient becomes 0, we have to go on dividing this given decimal number by 2. 2 4s are 8, remainder is 0. 2 2s are 4, remainder is 0. 2 1s are 2, remainder is 0. Next 2 zeros are, this quotient will become remainder. The first remainder is least significant digit and the last remainder is most significant digit. So we'll have to write the binary equivalent of number from most significant digit to least significant digit. So we have to write 1 0 0 0. Next, how do you write 1? So even 1 can be divided by 2. Here you can say that as per basic mathematical rule says that when the numerator is less than denominator, then the numerator act as a remainder, quotient becomes 0. Here remainder is 1. So in order to match up all of these 4 bits, we have to write this 1 can be written as 0 0 0. So these 3 are called leading zeros and then we have to write 1 over here. Now let us subtract bit by bit from the right hand side. I cannot subtract 1 from 0. So what I can do is I want to borrow 1 from the leftmost column. So here also we have got 0. Again check for bit number 1 from the next left column. Here also we found 0. Again you can check out for bit number 1 on the left hand side column. Here we found 1. So you can shift this 1 over here. Correct? So this 0 will get cancelled. This bit has shifted, it will become 0. So where exactly we want this 1? We want it here. So again shift this bit number 1 over here. This 0 will get cancelled. So again you can see that we have to shift this one on the right hand side. So 1 0 will become 2. Just now we have studied that 1 0 is 2. 1 0 is 2. 2 minus 1 is 1. So 1 minus 0 is 1. 1 minus 0 is 1. 0 minus 0 will become 0 and we have to check out that whether this 0 1 1 1 is equal to 7 or not. How to check? We'll use this method. The positional weight of this bit number 1 on the right hand side is 0 1 2 3. Alright, 0 into 2 to the power 3 plus next bit number 1 into 2 to the power 2 plus next bit is 1 into 2 to the power 1 plus the last bit is 1 into 2 to the power 0. So 0 into anything will become 0 plus 2 to the power 2 is 2 2s are 4, 4 1s are 4 plus 2 to the power 1 is 2, 2 1s are 2 plus 2 to the power 0. Anything raised to 0 is 1, 1 into 1 is 1. Here you can see 4 plus 2 is 6, 6 plus 1 is 7. So whatever we got in binary notation, that is absolutely correct.